game changer. I'm a risk taker.
Hi, Assalamualaikum warahmatullahi wabarakatuh. We are RoboPrime and we are participating at the RoboCup Asia-Pacific 2021 Aichi Japan at the category RoboCup CoSpace Rescue Simulation Under 19 from Airlangga University, Indonesia. At first, may I introduce myself? My name is Faiz and this is my friend Touch. Me as a strategy planner and my friend Touch as a programmer and evaluator. We are from Indonesia and we have experience, me have experience at the gold prize for creative robot category, Asian Robot Olympiad Singapore 2016, and my friend Touch has an experience at second place RoboCup Soccer Singapore Open 2017. Our exclusive summary of preliminary challenge is our task to collect as many points as possible. And what challenge we are participated on is RoboCup CoSpace Rescue Challenge Under 19. And problems we investigated is that we have to deposit the object, avoid the traps, detect, and pick up super object. We have methods is depositing if the load objects are more than 0, turn right or turn left, and program the RGB to detect and program the robot to go to super object coordinates. Our result is the robot executed well. Our conclusion is we have to develop our program more because sometimes there is a problem at the yellow boundary. We have an analysis at the challenge mission. We have to gather point as many as possible. There is some mini task. The first one is the blank spot and the yellow boundary, and the last is yellow trap. Will the overall mission solve if above mini tasks completed? Yes, it's solved because the mini tasks are completed and executed well. And then we have several algorithms and resources. The first one, if super object generated after deposit the object, then the robot will be directed to the super object. The second one, if there is a blank spot, we go through it and increase the speed. And then the third one, we make an interval at the color object. The robot can still detect the object even the robot is moving fast. And then the last one, we know the algorithm of the program is running successfully by monitoring and viewing the debug screen. And then we have several problem methods and results. Our first problems is the robot must avoid yellow boundary. Our methods is reduce the robot space using the X and Y lines boundaries at the top, bottom, right, or left. And then the results is robot can avoid the yellow boundary precisely and turn around. And then the second problems is the robot must avoid yellow trap, like this picture. And the methods we use is the programs the robot with RGB sensor to detect yellow traps, then avoid with a right speed. Then the results is the robot can avoid the yellow trap properly and turn around. The third problems is when the robot has a high speed, sometimes the robot has a struggle with detecting the color of the object. And then we have methods that from the RGB sensor color data, we add an interval 10 in the max and less than 10 in the minimum. And the results is the robot can still detect object correctly while the high speeds.
In problem 4, the problem is there is a blank spot that will trap the robot. The method is we set the robot through the blank spot and increase the speed. And the result, the robot can go through it at a really efficient time.
Okay, and then we have implementation. We draw in at the flow chart here. First, we start the robot and then going forward. And then the RGB sensor detecting the color object. If detect current object, if it yes, it will pick up, the robot will pick up the object. If it no, the RGB sensor will detect red object or the black object. And then if it it was yes. It was pick up the object. The robot was pick up the object, and then if it no, the robot will going forward again. But after the robot pick up the object, if loaded object are more than 0, the robot will deposit the object to the deposit box, and then going forward again.
Debugging advanced action for super object. As we know, the super object have a big score. So we program the robot to locate super object and go to the super object. Debugging detect object. Sometimes our robot didn't detect an object while in high speed. So in the RGB of each color object, we add 10 in the maximum and lessen 10 in the minimum. And the result, the robot can still detect the object precisely. Debugging blank spot. Our team realized blank spot affect our robot movement. So we program the robot. If there is a blank spot, the robot will go through it and it increases its speed. And the result, the robot can go through it and it really efficient time. Conclusion and further work. A robot will actually experience a few errors, and occasionally the robot sensor isn't always running optimally beneath sheer circumstances. We as a builder need to be capable to discover an easy and suitable method to clear up those troubles and use the grid method on our robots. By the use of this method, we will reduce mistakes in our robots so our robots can complete the missions quickly and precisely. Learning experiences. By taking part in this competition, we are able to analyze new knowledge about virtual robot programming and a new experience. In the future, we hope that we may be a greater innovator and creative in developing fantastic techniques that will be implemented in our robots. So that's all from us, RoboPrime. Thank you for your attention. We hope you all enjoy our presentation. See you.